Assalamualaikum. I am Izzah Fatini. I would like to share with you guys about the processing and refining of oil and fat with my partner Shohada binti Zulkifli. So first and foremost, I would like to give you a little bit introduction about crude fats and oil. Okay, so crude fat and oils consist primarily of glyceride and glyceride. However, they also contain many other lipids, but in minor quantity, which means majority of the compound of fats and oil is glyceride, and the minor part is lipid only. And all crude fats and oil can be obtained after the process of rendering, crushing, solvent extraction. But even though we do the process, it will contain a variable amount of non-glyceridic constituent. For example, this table actually shows the non-glyceridic constituent, which are free fatty acid, phosphatide, steroid, carotenoid, and other metals such as ferrum and cuprum. And some of these materials are highly undesirable, and we have to remove them in order to get a good processing characteristic. And we also want to provide a desirable color, odor, flavor, and we also want to keep the quality of the finishing product. So how to remove the undesirable materials? It is by refining process. The general method employed to produce an edible oil that's suitable for human consumption, which consists of 7 to 8 method, which is first is seed preparation, extraction, degumming, neutralization, bleaching, deodorization, hydrogenation, or sometimes use winterization. So first, for the seed preparation, first we will when oil seed are received at the oil mill, when we receive the oil seed, we will clean the oil seed using magnet, screening process, and aspirator system. And then we will clean the seed. We will dry the clean seed in order to remove the moisture. So our next step of process will be more clear and smooth. And then the dried oil seed are decorated in order to remove the hull that surround the oil seed, which means we will dehulling or deshielding the oil seed. And then we will cut them, and then we will separate the hull and the seed by screening and air clarification. So I have provided with you a video. Okay, this is actually the screening process. They will separate the shell of the seed. Then they will screen the oil seed here. Okay, in order to get a good oil seed for next process. So second process is extraction. So the purpose of extraction is actually we want to maximum the amount of good quality oil, and then we want to get maximum value of the residual press, cake, or meal. I will explain it later. And then there are 3 methods in extraction, which is rendering, pressing with mechanical presser, extracting with a volatile solvent. Volatile solvents such as heptane or hexane. So the first one is rendering. So rendering is actually a process that converts waste animal tissue into stable and usable material. So rendering process is applied on a large scale for the production of animal fats. So how do the process occur? So first, we collect the fatty tissue from the animal, and then we chop into small pieces, and then we boil them in a steam digester or any boiling water. And then so what happened, the fat will gradually liberated from the cell, which means the fat will move out from the cell, and then it will float on the water, and then we can collect them by skimming, or we can filter like picture that I show here. Okay, so this is a rendering process. It's a simple process that we can do it at our home. So the second method is pressing. So basically, oilseed does not have fat cell like animal. Animal have fat cell for storing fat, but in oilseed they store fat in microscopic globule throughout the cell. So we cannot use rendering process to extract the oil from the seed oil, because rendering cannot break the cell, cannot break the cellular structure of the oil seed. So we use pressing in order to liberate the oil from the cellular structure, and then the cell wall are broken only by grinding and flaking, rolling, or pressing under high pressure. So this picture is show you the screw press. I will show you a video about the screw press later. So the general sequence of modern operation in pressing oilseed and nuts is as follows. So first, we will prepare the seed in order to move the metal and to remove the hulls, like the seed preparation that I explained before. And then we will reduce the size of the oilseed by grinding, and then we go further for pressing. We will further the process by pressing and cooking and pressing by using hydraulic or screw press. So this is the video of the extraction stage using screw press. So this is the structure of the screw press cross section. And then okay, we have the inlet and outlet here. And okay, first we will insert the oil seed that we cut into small pieces, into the small size, and then it will flow through the screw here, and the screw will keep rolling like that. Okay, and at this part the oil will be released along the cage, and then at the outlet part will be the press cake. So this is the press cake. The press cake is actually the leftover of the oil seed, but in the form of solid. So the leftover will be discharged into the conveyor, and then will be removed for subsequent processing. Next, there are two types of oil, extraction oil. Okay, first, oil expressed without heating, and second is expressed with heating by cooking actually. So for oil expressed without heating, it will contain least amount of impurities, and then it's suitable for it. The quality is like edible quality. So we we do not need to refine for the refining process or for the other process. Example of the oil press without heating is cool drawn. Cool drawn is for example castor oil. Castor oil is uh, is is an oil used for hair treatment, and then cold pressed is like a cold pressed coconut oil and virgin oil. We have so much virgin oil, linseed oil, and something like that. And then for expressed oil from cooked seed, it will contain greater quantities of non-glyceridic impurities such as phospholipid. Okay, you can refer for the table 4.9 that I explained before. And then this oil will have highly colored and they're not suitable for edible use.
Okay, the third method in extraction is solvent extraction. So from the previous method is pressing, so the final product will be oil and the pressed cake. So the pressed cake is actually still retain about 3 to 15% of residual oil. So we have to use solvent extraction to complete the extraction. So the common solvent for edible oil, we use hexane or heptane, commonly known as petroleum ether, and because the boiling point is about 63.3 degrees Celsius to 68.9 degrees Celsius, which is less than oil boiling point of oil. So after the extraction, the maximum solvent recovery is necessary for economical operation. So the solvent is recovered by distillation and is reused again. And then the extracted milk contain less than 1% of residue. So after we complete the solvent extraction, the extracted milk akan contain less than 1%. So next, now we move to the third method to produce edible oil, which is degumming and neutralization by refining process. So in refining process, so involved in two process is degumming and alkali refining. So in the function of degumming process is actually to want to reduce the phosphatide and metal content in the crude oil. Phosphatide can be divided into two, which is hydrotable phosphatide and non-hydrotable phosphatide. In alkali refining, the NHP, they want to remove the NHP and HP by neutralization. So that is function of alkaline refining. So in degumming process, we will treat the oil with phosphoric acid and water, and that followed by centrifugal separation of coagulated material, which is lecithin. And then in refining with alkali, we want to remove the free fatty acid before rendering the extraction. So we will treat the oil with NaOH, which is sodium hydroxide, and then we heat the mixture to break any emulsion that form, and then mixture is allowed to settle, and then the settling cold food are collected and sold as soap stock. So in the continuous system, the emulsion is separated with centrifuge. After the oil has been refined, it is washed with water to remove the alkali and soap stock. After that, after water washing, we will heat the oil will dry by heating or filter. And the best process to remove the non-hydrotable phosphatide are known as the Union super degumming process, or we call it Unilever, and the top degumming process, Vendimortele. Okay, there are three types of degumming process. First is enzymatic, soft, and acid. So in enzymatic degumming process, the hydrotable phosphatide is enzymatically modified? It is because the modified phosphatide will facilitate the removal of NHP. So next is soft degumming. We will add the ETA to the oil in order to remove the cation from the hydrotable phosphatide. So you can see in this, okay. So from for the enzymatic degumming process, when we
the phosphatide,
when the hydrotable phosphatide is modified to be enzyme, it will decrease the amount of phospholipid. The P content is phosphatide content, and then the H2O will be increased because we add water for the enzymatic for the degumming process just now. So the phospholipid will be decreased from 0.6% to 0.01%, and P content from 240 ppm to 4 to 8. And then for soft degumming, okay, in here we can see that the phosphatide is attached to the cation. Okay, when we add ETA, the phosphatide will free from the cation, and the ETA will be attached to the cation. Okay, for acid degumming, in order to improve the acid degumming process, the special additive are mixed to improve the wetting of NHP. Okay, so
it will
enhance their solubility in aqueous phase. So bila dia dah wet, the NHP is wet, so it's more easy to dissolve in aqueous phase. So and then the contact between the reaction product and the phosphatide is ensured to improve the hydrotability of NHP and the efficiency of their removal. So it's more efficient to remove the NHP. So for the conclusion for degumming and neutralization, it said that all degumming process, the efficiency of degumming treatment is depend to a great extent on the quality of the crude oil. So the quality of the crude is also important for the efficiency of degumming process. And then a good quality fresh oil will make it easier to be degummed than the adulterated oil. And then this is a direct sequence from NHP to HP ratio. And the lower the NHP content, the easier the degumming procedure, and the better the degummed oil yield. So next, so this is the generalized flow sheet of degumming process. From the crude oil, we add water and make separate in order to separate the hydrotable HP, drying, and we use lecithin. And then for water degum, okay, water degum is soft degumming. And then we go to acid degumming process. And then the next method will be bleaching, and deodorization. It will be explained by Nur Syuhada. Okay, that's all for me. Thank you so much for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syuhada Binti Zulkifli. So I will proceed with the bleaching process. So bleaching process is a process when we want to reduce the color by absorbing the color pigment, impurities, and unwanted metals using bleaching earth or activated charcoal or both. So bleaching earth basically is a composed of the three types of clay, and one of them is bentonic clays. So natural bleaching clays are aluminum silicates, and this bleaching process is by far the most expensive process. So we take a look at bleaching process. It's undergo 3 stages. So first of all, mixing oil with the bleaching earth. So bleaching earth acts as the absorber when it's absorb all the impurities that we want to get rid from the process, and then oil heating under the vacuum to make sure that it's not reacts with the others. And the last one is filtration on hermetic leaf filters. So this is the figures of the hermetic leaf filters. We undergo these filters because we want to remove the spent chemicals. And polishing filtration. For filtration, we want to make sure that the final filtration step. Okay, this is single filtration bleaching. So you can see from crude oil. Crude oil is that like petroleum oil that come from the earth. And then primary, centrifuge, select, silica slurry, and okay, you can observe it. Okay, next is I will explain about deodorization process. So deodorization process is process when we want to remove the free fatty acids and volatile odoriferous components to obtain the bland and odorless oil. So most fats and oils, even after undergo different process, still have characteristics, flavors and odors. So that's why we undergo this process. So the efficient removal of undesired substance depend on there are four things where affects the efficient of removal of undesired substance. So one of them is the vapor pressure of the different minor compounds, then the deodorizing conditions, the amount of stripping steam, and the last one is the geometry of the vessel. Okay, so as I told before, deodorization process is a stripping process in which a given amount of stripping agent, usually we use steam, through hot oil at low pressure. So this is a figure how the deodorization process undergo. Okay, first heating. So oil will be heated at a very high temperature, and then deodorization or steam steeping where we use steam. Next is heat recovery, and next one is final cooling, and final cooling process we use water, and the last process we use deaeration process. So deaeration process is process when we want to remove the oxygen and other dissolved gas. So why we undergo this process? We can make sure that we want to make sure that there's no oxidation occurs during this process. Okay, next is sterilization process are used in both batch and continuous. So batch basically is suitable in a small capacity. It's like less than 50 tons per day, while the continuous with a large capacity. So next, okay, we proceed with hydrogenation. Hydrogenation process when we use to convert liquid fats to plastic fats. So this is the example from the liquid fats, the oil undergo this hydrogenation to form plastic fats. It's, for example, shortening, steam measuring, and so on. So this process also exhibit improved oxidative stability and color. So we have learned before that how hydrogenation occurs. Okay, so in hydrogen process, the hydrogen is added direct to double bond of fatty acids. So from the unsaturated to the saturated because we add hydrogen at the double bond. Okay, next. Usually in this process we use nickel type and copper as a catalyst and reagent because of their stability and high catalytic activity at room temperature. So next is variables affecting hydration. These are several variables that affect hydrogenation. One of them is catalyst, temperature, hydrogen pressure, and amount of agitation. So the catalytic hydrogenation is accompanied by isomerization. So for example, for oleic cis, isomerizing to LID trans acid. So we learned before that cis is the same group as on the same side, while the trans are on different side. So the trans isomers are much higher melting point than natural cis forms. This is because their structure. So the trans isomer is like a linear structure, while the natural cis forms is like king in their shape. So because of the king in their shape, so it's difficult to pack their molecules together in the stable crystalline lattice. Okay, so winterization process, also known as fractionated crystallization, is a process of removing from certain oils and the components that solidify at a low temperature. So we want to remove the component that solidify at low temperature. So it's basically not all types of oils that we undergo this process, but this process strictly used for the oils such as cottonseed, fish, rice bran, and partially hydrogenated soybean that contain long-chain or highly saturated fatty acids that during the long-term storage or refrigeration will make the oil cloudy. So to prevent the clouding, the high melting fraction are crystallized by chilling and then separate from the oil through filtration or centrifugation. So you can refer to this structure. Okay, next is winterizing process. It's conducted in 4 steps. One of them, the first process is the oil is pre-cooled in heat exchangers. Then the filter aid is added just before the first catalyzers, and then oil is cooled and cooled slowly in a minimum of 6 hours, a prerequisite for gentle crystallization. So next is the crystallized form stay 6 hours in the macerator at final cooling temperature. The last one is the oil is then filtered in horizontal hermetically filters. I already show you how these figures on the slide before. The oil temperature is often raised just before filtration. This because we want to reduce the viscosity and facilitate filtration.
Alright, so Assalamualaikum warahmatullahi wabarakatuh. Alright, so next we're going to look at topic 8, which is fats and oil stability and antioxidant. So without further ado, let's get started. Alright, so stability. What exactly is stability? So by definition, stability is the capability of a fat, oil, or fatty acid to retain a fresh taste and odor during storage, which means that the higher the stability, the longer a fat, oil, or fatty food can stay fresh. And the stability is related to the ester linkage of triglycerides, which can either be subjected to lipolysis or oxidation. Alright, so what exactly is lipolysis and oxidation? Let's take a look. Alright, so lipolysis. Lipolysis is actually a hydrolysis that liberates free fatty acids. So lipolysis is a process that hydrolyzes the triglyceride ester linkage to form free fatty acids and glycerols. And this can occur from chemical, enzymatic, or thermal stress actions. And lipolytic spoilage or spoiling due to lipolysis is also can be known as lipolytic rancidity or hydrolytic rancidity. Okay, and fats and oils also can become rancid or spoiled as a result of oxidation, like I've mentioned earlier. And this oxidative spoilage is known as oxidative rancidity. Okay, And it says down here that lipolytic acidity usually is less likely to cause flavor problems in those fats, oils, and fatty acids due to it only develops flavor problems or bad taste if it contains short chain fatty acids, which is less than carbon 12, which is less than 12 carbons. Okay, all right. Next, we're going to look at oxidation. So for the oxidation part, the reaction of oxygen with unsaturated fatty acids in fats and oils, which proceeds through a free radical chain reaction mechanism involving 3 stages. So for oxidation spoilage, we have 3 steps, which is initiation, propagation, and termination. So initiation is the process of forming the free radicals, and propagation is the where the free radical chain reaction occurs, and last but not least, termination, which I think we're all familiar with, which is the formation of non-radical products or the termination of the free radicals. So right now we're going to take a look at the mechanism of the oxidation. Alright, so here you can see here, I love Ana Muslim. Alright, so just ignore this. Alright, so oxidation or oxidation mechanism, or you can call oxidation process is also autooxidation. So its other name is also autooxidation. So autooxidation mechanism, we're going to look at autooxidation mechanism. As I've mentioned earlier, it involves 3 steps, which is initiation, propagation, termination. Alright, so for the initiation step, here we have a alkyl group, or of whatever fatty acids that you want. We can put R as whatever fatty acids that you want. And here, and we can see here that there's a H attached to the fatty acid. And the initiation process starts when O2 or oxygen molecule comes and attacks the H atom, which is attached to the R, and this will produce a free radical and also water. Alright, so this is the initiation step, the formation of free radicals. Okay, so next, propagation. So in propagation step is the step where the free radical chain reaction occurs. So what I mean by this is here we can see that the free radical that is formed earlier is being attacked by another O2, and this will produce a ROO radical group, and it's not actually radical, ROO radical group. Alright, and so this ROO group will attack another fatty acid, RH, and takes its H, that will attack another H attached to another fatty acid, and then will form hydroperoxide. Okay, and another free radical. So that's why it's called free radical chain reaction, because this first free radical will attack another fatty acid, and the chain reaction will continue. We're producing hydroperoxide and another free radical, and this free radical will be attacked by another oxygen, and the chain reaction continues. Okay, so follow me? Alright. So this substance here, hydroperoxide, is what makes the fats, oils, and fatty acids go bad, or rancid, or spoiled. This here, hydroperoxide, this compound provides the off flavor, the bad taste, and the rancidity. So this is what we don't want to happen. Alright, and the next step is, and after many hydroperoxides have been produced, then comes the third step, which is termination. So in this termination process, as always, the free radicals will be terminated and produced non-free radical. Okay, so like this. So R meets R, and then RR, ROO meets R equals becomes ROOR, and so on and so forth. Alright, so what I want to get into is here. Alright, so fatty acids, mainly unsaturated fatty acids like this, have all of them. What I'm trying to say is, a lot of them have this position here, where H in allylic position. So allylic position is a H that is attached to a carbon next to a double bond. So this H right here is very reactive. This is due to resonance. So if you all remember resonance, it can be stabilized by resonance, because this H here is very reactive, because if a free radical or if this C becomes a free radical, it is a stable free radical because it is being stabilized by a resonance. So yeah, so this H here is very reactive. And yeah, if this becomes a allylic, this allylic hydroperoxide is very common in oxidative rancidity. Alright, so I hope you get that. That's all for alkoxidation mechanism. Alright, so we're back. That is alkoxidation mechanism. Next, trace metals, especially copper, catalyzes this alkoxidation process by reacting with the hydroperoxide, which is produced in the propagation step, to create new free radicals and initiate new chain reactions. So the trace metal ions will promote the alkoxidation process to go on and on and on. So like here you can see the process. And then in order to avoid the alkoxidation problem, or this problem, it is common in edible oil industry or any oil industry to construct reaction vessels out of stainless steel to avoid trace metal ions that will interrupt the reaction. And citric acid is also often used and added in the reaction as a metal sequestrant to effectively inactivate trace metal ions. So a metal sequestrant is actually a substance that can bind with the metal ions, or in this case trace metal ions, and prevent it from interrupting the reaction. Okay. So next, antioxidant. So another thing that can also be used to avoid alkoxidation problem is by using antioxidants. So antioxidants are used to stabilize fats and fat-containing products against oxidation, and thereby prolonging their stability and storage time. And antioxidant acts as a free radical trap to terminate oxidation chain reaction. So basically it says that antioxidants can be used to stabilize or to prolong the shelf life of oils and fats by acting as a free radical trap to terminate oxidation chain reactions. And this step, the antioxidant attacks the free radical at the propagation step, and thus terminating it early, and stopping the alkoxidation process. And here we can see that you guys can see the examples of antioxidants. This is a few of the most common antioxidants used in industry, such as BHA, BHT, and so on and so forth. So yeah, you guys can take a look. Alright, so next we're going to look at the next topic. Alright, so Assalamu alaikum wa rahmatullahi wa barakatuh. We're back again, and this time we're going to look at the last topic of chapter 2, which is methods of analysis and testings of fats and oils. in this chapter, or in this topic, we're going to look at a series of tests and analysis of fats and oil that we can use in different circumstances to measure different things. So let's take a look. Alright, so let me adjust this a bit. Okay, alright, so this first series of tests is for identification and compositional analysis of fats. So the first test, or SN. So saponification number is the weight of coke in milligram needed to highlight a sample of an oil or fat. And in simpler terms, saponification number is basically the amount of potassium hydroxide needed to turn 1 gram sample of an oil or fat into soap. So that's where the in its name comes from. So for those who don't know, saponification is a process to turn fats and oils into soap. So yeah, that's where the saponification comes from. And it says here, the higher the SN, the lower the average molecular weight of the fatty acids in the triglycerides. And saponification number is basically used to determine the characteristics of the fatty acids inside the fats and oils, whether the fatty acids is long-chained or short-chained. For example, long-chain fatty acid has lower saponification number or saponification value. This is because when the length of the fatty acid increased, or when the length of the chain increased, the number of ester group per fat, the number of ester per grams of fat decreases, and this lowers the carboxyl group available for saponification, and thus lowering the saponification number. Okay. Alright, next is, alright, let me adjust this. Okay, so next, value, or AV. So acid value is very important for the determination of free fatty acids in crude and refined oils and fats. So it says here, acid value is the number of Co, or potassium hydroxide, needed to neutralize the organic acids present in 1 gram of oils or fat. So some of you may be wondering why this sounds very similar to saponification number. Well, it is different from saponification number, where acid value depends on the number of free in the oils and fats, while for saponification number, it depends on the characteristics of the fats and oils present in it depends on the characteristics of the fatty acids in the fats and oils. So it depends on whether the fatty acids in the fat and oil is long chain or short chained. While for acid value, it depends on the number of free fatty acids in the oils and fats. Okay. Alright. So alright, so I've adjusted the webcam for you so you can see better. So next we're going to look at iodine value. So iodine value is very simple. So iodine value is the value that measures the unsaturation of oils and fats in terms of the amount of iodine absorbed per 100 gram sample. So the method is simple: normal oils and fats not containing them. So iodine value basically is used to get the amount of unsaturation in fatty acids. So what is unsaturation? Unsaturation is basically double bonds. So it measures the amount of double bonds which will react with the iodine compounds. Right, very simple. Next is color reaction. So for color reactions, some oils give specific color reactions which is caused by a particular ingredient. For example, the Halfven test for detecting cottonseed oil. So you guys can just Google the Halfven test, and yeah, you will get the and all that. So if you want to know, just Google. Alright. Okay, so next we can also know the composition of fatty acids, and we can do this by using GC, or gas chromatography, and which I'm sure you are all familiar with, GC. So we can know the composition of fatty acids by using gas, and we can also detect adulteration in oils and fats by using a coupled HPLC GC, high performance liquid chromatography GC, gas chromatography methods. We can know or we can detect adulteration in oils and fats. So if you're wondering what is adulteration is basically the addition of something. For example, if you have an for example, when adulteration is when a manufacturer of olive oil, for example, is very expensive, and adulteration is basically when the manufacturer of olive oil puts other vegetable oils inside, or add other vegetable oils inside to fool you, because pure olive oil is very expensive, something like that. So that is adulteration. So we can detect that by using HPLC-GC. So we as a chemist can know if our oils and fats have been adulterated with. Okay. So yeah. Alright. So next is physical test. So you can pretty much read yourself. It is self-explanatory. The most important thing is the solid facts, or SFI, which can be used to estimate the percent of semi-solid fat on the basis of change in volume with temperature. So, which is very important in fat hydrogenation and interesterification process, which you have learned in previous topics. Okay. Next. Alright, so the last part is quality control test. So, quality control test is basically self-explanatory in its name. It is a series of tests used for quality control. Alright, so the first test is lipolysis. Alright, so the first test is lipolysis. If you remember, we've learned before in a previous topic, lipolysis is a process where the ester linkage of a triglyceride is hydrolyzed to form a glycerol and also a free fatty acids. So we can detect in oils and fat by using acid value. So we've learned that acid value is the measurement of the amount of free fatty acids inside an oil or fat. So we can detect the degree of lipolysis or the lipolysis in oils and fats by value. Okay. Next. Alright, so next we have peroxide value. So for the oxidation of oils and fats will lead to the formation of hydroperoxides, as we've learned before, which is also called autooxidation. And then these hydroperoxides will readily decompose to produce aldehydes and ketones and other volatile products. And these hydroperoxides can be determined by using peroxide value. So we can determine the degree of oxidation or autooxidation of oils and fats, and we can also determine the degree of formation of hydroperoxides. And the peroxide value is expressed in terms of milli equivalent of iodine formed per kg of fats. Alright, so and last but not least, we have the shelf stability test. So in this test, we will use active oxygen method, or AOM. So we can use AOM to determine or to predict the shelf life of the fats and oils, or how long the fats and oil can last before becoming rancid or spoiled. So how it works is the fat or oil will be subjected to an accelerated oxidation under standardized conditions, so that the signs of deterioration are revealed within several hours or days, as opposed to several months or something like that. So we can hasten the process of oxidation in a controlled test from several months maybe, or several years, into just only several hours or days. So we can pretty much predict the shelf life of the fats and oils. Alright, so I think with that is all from us. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh. I hope you guys have learned something new, and I hope you enjoyed the video.